Hello, everyone. At the moment, we have how many people connected? 18 people connected so far, 19. So I think we can, it's getting more and more people. We can start. Hello, everyone, and welcome to this very first Head Start webinar on the state of innovation, stakeholder needs, requirement for key enabling technologies, and use case selection. My name is Jean-Baptiste Cauget. I work at Videcom and I work on the Head Start project since January 2019, and I will be the main presenter today. How many people? 28, okay. So a couple of rules before we start the presentation itself. So as I said, this webinar will last about 1 hour with the first 40 minutes presentation where I'm going to present the first results of the project on these topics. And then we will have a Q&A time, 20 minutes open question time, where I will review the question that you will have posted in the question bar. So in the tool, you should be able to type in the question bar your question, and please include the slide number if you have a specific question on one topic, so I can come back to it. And this question will be answered at the end. If you have any technical issue or if you cannot hear me well, please type it in the chat box so we can do something about it before it's too late. And if you have any other specific requests for the project in general or for the project coordinator, you can write us an email at info@headstart-project.eu. So let's do a test with the chat. Can anyone type something in the chat just to make sure that it works and we can hear you? I mean, see what you type. Okay, we have some people. Great, thank you. So let's start then. So this presentation will be about the first step of the Head Start project towards testing and validation methodology for connected and automated driving functions. So first I will present the Head Start project in general. Then I will introduce the work package 1, which is the work package that we are going to talk about today, with the results on the 4 topics, which are the state of innovation and gap analysis, the identification of stakeholder needs, the requirement identification for key enabling technologies, which are also called CATs in Head Start for short, which are positioning, V2X communication, and cybersecurity. And the last topic of the day will be functional requirements and use case selection. Then we're going to talk about the next step for the project. And finally, we're going to explain how you can help us review our deliverable, how to do that, because you can also contribute. And finally, we'll have a question time where we're going to answer the question of the question bar. So the Head Start project is a European H2020 project with 17 partners that you can see are coming from all across Europe. You can see that on this tiny map. The project started in January 2019 for a period of 36 months. So it will end at the end of 2021. And it's coordinated by IDIADA, which is Spanish. And if you want to know more about this project, I suggest you follow us on social media. We have a Twitter account, we have a LinkedIn account, and if you're still using Facebook, there is also a Facebook account. The website, we also have a website, which is www.headstart-project.eu. And of course, there is the email address I presented earlier if you have some specific questions for us. Here is an overview of the different partners of the project. As I said, 17 partners from all across Europe. So that's it. The project objective. So the goal of HEADSTART is to define testing and validation procedures and methodology for connected and automated driving functions for level 3+, with a focus on 3 key enabling technologies, which are positioning, V2X communication, and cybersecurity. And we want to apply our methodology to different test instances, such as simulation, proving ground, or open road testing, or FOT. And we also try to focus 3 different types of user group that will use this validation methodology. So these are the OEMs, technology developers, or tier 1s. There's also the side on consumer testing, which are taking into account the view of the final consumer for the car. And finally, the homologation with type approval made by public authorities. The chart you can see here present the different steps of the project. So first, we want to identify what already exists in terms of methodology for validation and testing. Then we want to harmonize all what we found in this state of the art. And based on that, we are going to define our own testing and validation methodology for CAD. We will do, of course, some demonstration. And the goal throughout the project is to reach consensus by keeping a tight link with experts such as you and having our work reviewed regularly in order that we stay close to the needs of different stakeholders. The first work package and what we're going to talk about is mainly on these 2 first steps, so identify and harmonize with the state of innovation, the stakeholder needs, the requirements for key enabling technologies, and the use case selection. So the goal of this first work package is to develop a comprehensive technical analysis and gap analysis on what already exists in terms of testing and validation methodologies through 4 steps. The first steps will be to analyze the existing state of the art and what exists in terms of testing methodology for CAD. The second step is to ask different type of stakeholders and target groups in order to have their opinion on different topics, and especially prioritization of use cases, which use cases would be best to test in HEADSTART. The third step is to identify the functional and technical requirement for CATs. And the last step is to select the most relevant use cases based on the 3 previous steps and identify the functional requirements for these use cases. So I'm going to talk about the first topic of today is the state of innovation, state of the art, and gap analysis that has been done at the very beginning of 2019 and was led by IKA, which is also present in the call. The objective of this task was to provide a detailed analysis on the validation and testing methodology for CAD and identify the main gaps based on what we found. So we have 7 topics that were developed. Most of them were, of course, focused on safety assurance for connected and automated driving functions. So we have first a state-of-the-art on terminology and taxonomy, state-of-the-art on scenario concept, different research projects based on safety assurance, the initiatives, the tools for safety assurance, the legislations, and finally the methodology. On the first point, the terminology and taxonomy, to have a short summary of it, we've analyzed a certain number of projects and standards to identify the most commonly used terms that we can put in our glossary. So in terms of standard, we mainly based ourselves on the German standard DIN SAE spec 91381. And we also based ourselves on the SOTIF, the safety of the intended functionality, which is the ISO PAS 21448. So the selection of terms from all these projects, sometimes you had duplicates, sometimes we had some terms that have multiple meanings, and sometimes we have the same concept expressed with different terms. So we did a round of selection according to some criteria, and in the end we came up with a glossary, a unified and unambiguous glossary of about 45 terms. Regarding the taxonomy that we found for automation levels, the most famous, of course, is the one from the SAE. So the very well-known 6 levels of automations from 0 to 5. But we also found other models, mainly from BAST and NHTSA, where there is 5 levels of automation from 0 to 4. So this table is on the right, the little summary of that. Regarding the scenario concept, I'm not going to go too much into the detail, but a certain number of projects, European project and national projects from a little bit everywhere, as you can see, were analyzed in order to find what most people do for defining the driving scenarios. So you have the German project Pegasus. There is the MOVE project in France, TNO Streetwise in the Netherlands, L3 Pilot, of course, the European project, and also the Sakura project from Japan. Talking about research projects, we also found a lot of different research projects linked to mainly the testing, definition and testing activities of CAD, and also we tried to find some projects that were focused on the HEADSTART CATS, so communication, cybersecurity, and positioning. And here is an overview of all those projects that we've covered and that we described in our state of the art. Regarding the initiatives, same thing. 22 relevant initiatives were found overall that are interesting for our topic. Some are from manufacturers associations such as JAMA, ACEA, PFA in France, OICA International. Some of them represent public authorities. Some of them are more focused on CATS, such as 5GAA. We also, of course, have the consumer testing ones for example, Euro NCAP, as well as a lot of different others that were analyzed and doesn't necessarily go in a box, but still interesting for the HEADSTART project. Here is an overview of the localization of the different initiatives. As you can see, most of them are European or international, and some of them are national. Regarding the tools for safety assurance, the objective of HEADSTART was to list the main tools that were relevant for testing and validation. Of course, it's not limited to that, but here is a first example of what we found in our state of the art. So you have the annotation tools that add the addition of relevant metadata. We have video annotation tool, 3D annotation tools for 3D content, and also some from web platforms. In terms of recording tools, which is the synchronous raw data acquisition, we have RT Maps, Polysync Core, IDIADA, EDAPT, etc. We also have some simulation tools that were analyzed, such as NVIDIA Drive, Microsoft AirSim, and then, of course, some other tools for proving ground testing, such as the dummies, like the global vehicle targets, or some software to control those dummies, such as ROS, Robot Operating System, or ADTF. We also did a state-of-the-art on the legislations, and a lot of documents from European or non-European legislation, national legislation, different standards and guidelines were analyzed in order to find everything that already exists in terms of testing and validation for connected and automated driving functions. I'm not going to detail them that, but those state-of-the-art are now available online on our websites. I'll talk about that a bit later. In terms of methodology, similarly to the scenario concept, we found in different connected and automated driving research projects that the methodologies can be quite similar in the way they work. So first you have the collection of data of real-world driving data from field tests or naturalistic data, and then from these data you extract the scenario in a scenario database, and then in the end you evaluate those scenarios in order to test your function. So this is a very short summary of it, but this methodology is further detailed in the future work packages. So that's all for the state of the art. Now I'm going to talk about the identification of stakeholder needs, which is the second task of this work package one. This topic was led by Bedecom, and the goal was to identify the needs on methodologies and procedures, tools or standards from the viewpoint of different stakeholders. So what we call stakeholders are, we have, if you see on the right of this little table, you can see that the types of stakeholders are the OEMs, the automotive suppliers, the public authorities, the consumer organizations, research institutes, or universities. And all these stakeholders were interviewed through a different mean of collection of needs, such as face-to-face interview, phone interview, targeted survey by email, or online survey that is anonymous. And there was 6 different topics of interview. So the first one was the use cases and scenarios. We had also something on safety, safety assessment, and safety case. We had a presentation of testing, how to test connected and automated vehicles, something on certification, something on consumer testing, and finally something more focused on the 3 key enabling technologies, how to test positioning, V2X communication, and cybersecurity. So I'm going to quickly present the results of these interviews. So first of all, quantitative results can be shown here. So we had a total of 20 people interviewed by phone or face-to-face, and we also had 24 targeted survey by email. So this was the first step of our work. And then we also created an online survey that went online for quite a while, where we had not so many answers, but still 14 people answered our online survey. So regarding the use cases, the first topic of interview was to ask the different stakeholder, what is the main use case? What is the priority use case that we should take into account for HEADSTART? And here you can see the main results. We had at the beginning 6 different use cases, which were highway pilot, traffic jam chauffeur, valet parking, urban pilot, urban automated shuttle, and finally truck platooning. You can see that the relevance for how many people interviewed. This is the percentage that you see here. After doing a workshop in the Eindhoven in June 2019, we decided to discard the urban pilot one because it seems like for many experts this use case was too complicated to put in place. So we decided to not consider it as a priority use case anymore. Regarding safety assessment and safety case, we had 2 objectives. First of all is to identify the main risks that are introduced by CAD functions. So those risks that we identified are some of those. So the main one would be misusing the system or not respecting the ODD. For example, being able to start the automated function if it's made for highway, start it in an urban environment, for example, would be a high risk. We had the risk of encountering an unknown scenarios that the car cannot deal by itself. We also had some risk linked to software updates and bugs, some risk linked to cybersecurity, criminal activities, or cyber attack. And the final last risk would be the loss of positioning or connectivity that also was mentioned quite a lot. The second part was asking the different stakeholders, what would be, in your opinion, the best approach to take to ensure the safety of the connected and automated driving functions. So most people agreed that the scenario-based approach would be the best one with a combination of different test instances, such as simulation, open road, test track, and that in terms of tools and procedures, the SOTIF, the safety of the intended functionality, was a good start in complement to the traditional ISO 26262, which is the basic for functional safety in the automotive industry. We also noticed that there is no current legislation for the safety of CAD for the higher levels of autonomy, which are the level 3+. Regarding testing, the stakeholders were asked about the main testing level in their companies, and it turns out that so far most people are testing level 2 and 3, but are starting to evolve to SAE 3+. And most tests would be done for performance testing or validation testing. We also noticed that there is no fixed or commonly used methodology for testing apart from sometimes the Euro NCAP protocols. And so the conclusion would be that there is a need for a common methodology and protocol. So that would be one of the objectives of HEADSTART. Regarding certification and type approval, the objective was to identify the needs for this, and the main concept that were found was, and discussed a lot, was the 3 pillars from OICA for certification. So I'm not going to detail them too much, but basically the goal is to certify the CAD vehicle with 3 different steps. So audit and assessments through simulation, then physical certification tests, and then finally real-world test drive to assess the overall system capabilities. Regarding consumer testing, the needs were mainly on safety assurance and safety benefit. It turns out that if we talk to people from type approval, they will be more focused on safety assurance, like how many lives could be saved and how many accidents can be avoided by the AD function. And if we take the point of view of consumer testing, it's a little bit different, because we focus more on the safety benefits of the function. Is the function able to perform as expected without adding any risk to the driver or to other road users? So what was analyzed as well is the Euro NCAP 2025 roadmap with the new features that will be tested in consumer testing, such as driver monitoring, autonomous emergency braking, child presence detection, and other features such as automated driving, cybersecurity, track and power two-wheelers, this kind of stuff. For the needs on testing cats, the main activity done in this task was to find the most interesting use cases to test the key enabling technologies, and so asking the different stakeholders, we see that several use cases were mentioned, and the one that you can see in red are also the one that were described as a priority use case for the project in general. So that it turns out that there is a similarity between those. So the main ones would be highway pilots, automated shuttles, urban truck, automated truck platooning, and traffic jam chauffeur. Now we're going to present a little bit the requirements identification for cats. This topic was led by SAFER, and the goal was to identify and compile the different requirements based on the previous analysis that were made in the state of the art or in the collection of stakeholder needs. So you can see there was a different type of requirements that were described. I'm going to show them to you in a moment. So for each key enabling technology, here is for positioning. We listed from a lot of different research projects and from the user group needs collections, the different requirements that we could have for each cats. So for positioning, at the requirements at vehicle level could be that the system shall be able to provide positioning at 10 Hertz. And it should be also able to detect and evaluate GNSS uncertainty. For technical constraints at component level, the system shall be able to provide longitudinal and lateral positioning within 10 centimeters. Regarding the safety for road users, the vehicle should be able to reach a safe state when there is a loss of positioning or when the positioning function is degraded. Potential physical constraints on test track can be that the test track should of course allow GNSS connection, should have some HD map of the test track available, etc. And the technical requirements for how can they be verified by computer tools, which is simulation. So the goal is to have a proper simulation under different weather condition. So how to simulate those weather condition close to reality. For V2X communications, here are some other example of requirements that we found. So the system should be connected to the infrastructure in terms of V2I. We can have some connection through traffic lights with ITS 5G, 4G LTE, or 5G LTE. The system should be able to support high connection density for congested traffic. For the technical constraints at component level, one roadside unit shall be able to communicate with about 200 user equipments. For the safety, the vehicle must be able to reach safe state even if there is a failure of the communication part. Physical constraints on test track can be that we should not have any other radio transmission if the test is carried out in open air in order to not influence the testing. And if it's not carried out in open air, if it's in a shielded chamber, we should not have any other radio transmission at all. Regarding the technical requirements, the simulation part, the tool should be able to define and reuse the test sequences of V2X messages. And for the technical feasibility, V2X is still being developed, and they need to meet the request requirements that might not be available yet. For cybersecurity, we have also a lot of requirements that were found. All those requirements, you will be able to see them in the deliverables, and I'm going to explain that a little bit later. So one example could be that the V2X message reception shall be signed by a trusted third party. For technical constraint at component level, some measure should be applied for all components of the system to ensure end-to-end cybersecurity. For constraints on test track, the potential cyber attack shall be analyzed from the defender's side and from the attacker's side. So both points of view should be represented. For the simulation part, we have a different type of testing that can be done, such as the Terra analysis, which is the threat assessments and remediations analysis. We can also do some penetration testing or fuzz testing. For the technical feasibility, finally, the function, of course, needs to be developed following the best practices for cybersecurity. And now we arrive at the last topic of today for the work package 1, which is the functional and requirements for use case selection. So how did we do to select the use cases for the HEADSTART project? So this task was also led by SAFER, and we first collected different requirements that we wanted to put in place for selecting the use cases, and then we based on the pre-selection that comes from the stakeholder needs. We did a selection of use cases and gave a score to each use case. So we have different categories of requirements. So first of all, we need to be able to test each key enabling technology. So positioning, cybersecurity, V2X communication. Of course, we need to cover a different type of test environment, such as proving ground, field operational test, also simulation. We had some requirements for model-based testing. The scenarios for testing those use cases needs to be available. We need to have a potential collaboration for this use case to do the tests themselves. And finally, this use case needs to be relevant to the key user groups, OEMs, tier ones, type approval authorities, and consumer testing, which are the three main end users for HEADSTART. So here is an overview of the results of our analysis. So for each requirement, we gave a grade to the use case that were pre-selected. So those use cases you can see on top: truck platooning, highway pilot, traffic jam chauffeur, valet parking, and urban automated shuttle. So we had a series of requirements. You can see the first ones were requirements for testing CADs, then requirements for testing in general, the availability of scenarios, the collaboration of partners for this use case, and the relevance to key user groups. And for each use case, we gave a grade for all these type of requirements. And the result of this is this table. So the higher ranked use case is a highway pilot. That would be the priority use case for HEADSTART, followed by truck platooning, then valet parking, traffic jam chauffeur, and finally urban automated shuttle. So now I'm going to talk about the next step for the HEADSTART project. So what you've heard today is something that took place last year in 2019, from January to September, where we did all this work. And after that, the goal is to define our methodology, our testing and validation methodology that was handled in work package 2. After that, so yeah, we define the general methodology, we precise it with some dedicated procedures, and then we demonstrate our methodology with our different use cases. And the last part throughout the whole project is to keep a tight link with the different user groups and experts such as you through different events, conference, workshops, and in our case, webinars. So the goal is to involve the different experts so we are following the best practices. So here you can have an overview of the HEADSTART methodology, a little teaser. It's not the goal of today to explain it, but this methodology was created already. So here is a quick overview. So we have from the real world data, we extract some scenarios. Then those scenarios are selected for testing. We allocate those scenarios to different test methods, and then we do the testing itself with the different pass-fail criteria. So the next steps, how can you help us in being better? So the 4 topics that were discussed today, we wrote some reports on that we call deliverables. So if you go to the HEADSTART project website, if you go to the result to date and the deliverable, here is the address, but you should be able to find it quite easily from the front page of the website. You can download all deliverables and see much more in details what I've presented today. And if you have some suggestion for improvement, if you disagree with us on some point, or if you want to give us some further info on the topic, please write us your comments and suggestions at our email address, info@headstart-project.eu. So here is an overview. It's very easy to download. You should be able to see our work. So those versions are draft version. They are not definitive version. They were presented to the European Commission, but they are still open for review. So if you want to give us your opinion on them, please do. And now will be the time for questions. So I will invite Nicolas from IKA and Martin from SAFER to join me for answering the different questions. Nicolas, are you here?
Yes.
Hello, Nicolas. And do we have Martin in the call as well?
Yes, you have Martin here.
Okay, great. So let's have a look at what has been written already. Do we have any questions in the question bar? If you have some specific question, please write it don't hesitate. Let's have a look. For the direct communication, can you make it bigger? For the direct communication, you mentioned ITS G5. Are you also planning to use RTE V2X? That would be a question for Martin. So this question comes from Prachi Mittal. I hope I pronounce your name right. Martin, do you mind answering that? Because you're more expert than me on that.
I can guesstimate. I guess the exact technology, how to envision or to make V2X real is is not defined. It's defined by the use case, and the use case could be or the implementation of the use case could be any technology. So hopefully the process we are developing in work package 2 will be covering both radio and G5. G5 is the most commonly used among the use cases right now, though. So that's my question. That's my answer. We will hopefully cover everything. Some test cases will be specific for certain technologies.
Okay. I hope that answers your question, Prachi. Thank you, Martin. We have a second question from Scott Kovesti. The question is, given the timeline, there will be new safety efforts that come in during this project. What is the process to review new effort and consider their inclusion? So, of course, the safety is something that evolves all the time. And the goal is to stay close to those new projects through our state of the art will evolve. Of course, we keep in touch with the different experts, and we keep in touch with the new activities in conferences. So if there is something major in terms of safety that make us change our methodology, of course, we will take it into account. I hope that answers your question. Okay, so slide 10, we have a question from Stefano Becco that asks for slide 10. Let me go back to slide 10. It's on the terminology and taxonomy. His question is the glossary among public deliverables? So the first version of this glossary is available in the state of the art, which is the very first deliverable. But this glossary, of course, evolved with the project, so it is not the final version. And if you have any comment on it, you're welcome to tell us what you think about it, and if some terms should be used differently. So you can find the glossary there. You can find the 45 terms, but this might not be the final glossary for HEADSTART. Okay, we have another question from Maria Cristina Galassi. Are you also considering in-use data monitoring as feedback loop for safety assurance of automated vehicles? In-use data monitoring. Martin or Nicolas, any idea on that? Not sure. Are we considering in-use data monitoring?
I think one of the inputs in the process is field data, and field data monitoring will be one of these channels. Will also be incident reporting and insurance companies, and also from the developer side. I think Nicolas is better than me to answer this.
Nicolas, any idea?
Since we're building on a scenario-based approach and we're utilizing scenario databases, these scenario databases of course, are enveloping during the all the time. So there's also some in-use updates within the after the product is on the market. If this answers your question.
Okay, I hope that answers the question. So thank you for your question, Maria Cristina. We have another question from Scott Kovesi that asks, for V2X, do you have a position as to this being nice to have, or will it be required? I think V2X is required. We will, it's one of the main focus of the HEADSTART project. So it's not nice to have, but it must be represented in at least one of our use cases. So it's definitely one of the objectives of the project. If we have in the final use cases for HEADSTART, if we have some use cases that don't treat it, it's okay, but it has to appear in at least one use case. So yes, it's something that will be required.
Yes, I can add that truck platoon will be hard to implement without some kind of communication between the vehicles.
Yes. Any other questions from the audience? Thank you for your question, by the way, Stefano and Scott. A great question. So if that's fine for you, maybe we have questions for you. So in your opinion, we have another question? Okay. From Maria Cristina Galassi again. Do you see for central scenario database? Huh? Okay, can you specify a question? I'm not sure I understood. Do you see the need? Ah, the need. Okay, sorry. Do you see the need for centralized scenario database? Nicolas, you're the expert on that.
Could you repeat the question, please?
Do we see the need for centralized scenario database?
So within the HEADSTART project, we don't want to narrow down the different scenario databases, nor do we want to create our own scenario database. We want to define a common methodology, and within this methodology, we define the scenario database. From which project or from which country the scenario database is later used is quite open in the overall methodology. I think it would be a great opportunity if you have in the end one consolidated scenario database to boost up the amount of kilometers you have within this database, but we are not bound to that in the HEADSTART methodology.
Okay, thank you, Nicolas. Yeah, I hope that answered the questions. Thank you, Maria, for your question. Anything else? So as I said earlier, if you don't have any more questions, we have some questions for you because we still have a little bit of time. In your opinion, question on 5G. Yes, some question from Nazi Chiari, I hope. Question on 5G connectivity relevant here. 5G versus ITS. I guess the question is, which one do we consider the most relevant between 5G and ITS? I'm not sure how to answer that, but Martin, did you have any idea?
I guess you are referring to the 802.11p versus 5G. It's two technologies to transfer information, I guess. Hopefully, on a upper abstraction layer in this methodology we are developing, it will only be concerned. It will be agnostic to the technology used in the lower layers. But when you come down to the lower layers, there will be test cases or scenario, but not the scenarios, but test cases that are relevant for only 5G and only 802.11p or ITS. So hopefully we don't have to choose, at least on the upper abstraction layers. Whether we can exemplify them later on by demonstrating them, it will be another question.
Thank you, Martin. Thank you, Nadim, for your question. I hope we answered it well. Okay, so we're pretty good with the time. There is another point that we want to bring. Okay. So if you want to join us or join our discussion group on different topics of your interest, please have a look at our website, headstart-project.eu. There is a section called Get Involved, and we have, as you can see, 6 different topic discussion groups. So one on cybersecurity, communication V2X, positioning, scenario selection, consumer testing, and type approval. So if one of these topics is interesting for you, please have a look at the website, and I'm sure there is a way to add you to the email list. And when we will do the next event, which should be the 12th of May in Athens, if I'm not mistaken. Yes, the next workshop that we will be doing for the HEADSTART project will take place on the 12th of May in Athens, and it will be on testing and assessment methods, tools and approaches for positioning, cybersecurity and communication. So of course for CAD. So this will take place just before the L3 pilot summer school, if I remember well. So there is a way to register to this event on the website. Do we have, no, we don't have any more questions. So we still have a couple of minutes. So if you want to add more questions, we are available. And if not, thank you for your participation. And I hope to see you in one of our next workshops or one of our next webinars. So thank you, everyone. Oh, we have a question. Is there an event plan regarding type approval topics in 2020? I'm not really sure about that. Type approval, I'm not sure. I'll have to look it up, but all the workshops, certification, yes. Thank you, Bastian, for your question. I'm not quite sure yet. We do quite a lot of events, and if you take a look at the webpage, there will be everything you need to know there. Oh, okay, so we have an answer from article. So we will have something. Oh yeah, at the beginning we had an event in April, but due to the current virus situation, we had to cancel it. So it will take place later in the year, seems like. And thank you, Jaco, for your compliment. So I think that's all for me. We have a couple of minutes left, but if I stay online, and if you have any more questions, we will answer. But otherwise, thank you for your participation. Yeah. do we have anything from the chat? Thank you, David. Okay, so very good. Julia, are we good? I'm not sure regarding the amount of participants. Oh. So we will close it. Thank you, Julie. Let's close the webinar then.